there's one basic rule when you anything here with these, when you differentiate there, it stays the same. Did you get it? No, I'll leave it at that. So it stays the same.
Yeah.
So you just write what you've already got, but you've always got to remember the times by something. And what I always talk about, you're sick of me saying it, the derivative of the inside. Now, watch how complicated the inside is, that's how complicated it is. Now, student after student will write, they'll go 2 3s are 6x, and they'll go derivative of minus x's, minus 1, and they'll write it like that, and you will lose a mark. Just break it out. So then what can you do to write the final answer? You can put 5 brackets 6x minus 1. And you don't have to put the bracket around the top part, I just write it there for the understanding. Questions done? So you've got no choice, you've got to write that as an x to the half. And you've got no choice, you're going to move the bottom bit to the top. When it goes to the top, it goes from a positive to a, yeah, your brain works on that, aren't you now? Now you apply the rules. And the rules are, it stays the same. 4e to minus x to the half times by the derivative of the inside. Could have done that before, I could have gone like that and then gone like that. So 2 lots of arrows, derivative of the inside is?
Now I can move. Just write it down, I'll get it.
Yeah, so what does that bit there become when it's differentiated? So if I went over to here and I just said, we've got y equals minus x to the half and said differentiate that.
This is 1.5.
There's a 1.
Yeah.
So half times 1 is a half
X.
with a negative, and the half becomes a
Negative half, negative half, negative half.
when we're differentiating, we decrease the powers. So if you stay the same, the powers, normal everyday powers, that becomes a minus a half. So what makes it
I
a
can't
little
do it under
confusing?
pressure.
Yeah, I know. Let's slow you down again. Do it
No,
again.
that's all right. I can't say. I'll just write it down. I'll just write it down. I'll write this.
But maybe for some people you need to go aside and tidy it up. So that's a negative. There's a 1 on the numerator. There's a 2 on the denominator. And there's a square root. All that says is a square root on the denominator. Square root on the denominator.
Yeah.
And mate, if I do put this up as a video, you can go and watch it later anyway. So the last bit here is minus 1 on 2 root x. I'm tempted to say I'll leave it as that. But my mathematical brain wants to go and do this. I'd cancel the 4 with the 2. I'd go, wait a minute, that's a numerator. The e goes to the denominator. And the x squared becomes a, x to the half becomes a. So it's actually the square root of x. So the funny part is you started with the e to the square root of x and ended up with it again. Even though it's in a weird form, it still happens. So that's the square root of x on the denominator. So there it is. And then you've got also a square root of x on the denominator. Yeah, what? Pretty unusual. But what have I forgotten to write? One thing. There it is. So when you get messed up in the middle of something that's fiddly, tricky, you forget to put the negative in. Now, this is the big one. This one, what worries me here with my rearrange. We cannot differentiate on E on the bottom unless we use the quotient rule. We could use the quotient rule. Okay? But what do is we move the bottom to the top. I move that to the top. And what happens to the indexes, the indices? So that 1 will become a negative 1, and that negative 2 will become a positive 2. So you could have that in a test and go, I never thought about that. And yet the person writing the test or an exam will think, oh, we've taught you that. But it's different. I don't know if I've done one like that before. Have I? There wasn't any in the textbook like it. So now it's ready to differentiate. Now a lot of people by habit would go, well, I'm going to call that 2x minus 1. Because they don't like having the negative first and they prefer the x's first. Differentiate it. It's just either 2x minus 1. So col stays the same times by the derivative of the inside. Now if I didn't talk about derivative of the inside, I could just say stay the same. What's the derivative of this? Multiply at the front. So you could do this one with the quotient rule. So again, my experience is those who have done that in the quotient rule usually get it wrong. When I say usually, at least 2/3, probably 3/4. So all I'm going to do, what did I do to complicate it? This just had a 1 on the top, whereas this has got a 10 on the top. So the 10 stays there. The 1 becomes a minus 1, and the minus 5 becomes a plus 5. So we've rearranged. We do by habit have written that as 5x squared minus 1. What do we got? So col, if I looked at that, I just see that as 10x times 10. That's all it is. 2 5s are 10x, and then you go through that, we differentiate the inside. 10x times 10 is 100x. And it stays the same. Questions done.